In this video, I will show you how to create an application in ADSIRA SmartView using the main features. To facilitate learning, we will use a hypothetical project. In this project, we will develop a SCADA software, which is capable of monitoring, controlling and storing variables of two valves. Therefore, to develop this application, we will cover the following topics. Create a new project. Set screen resolution. Insert and configure tags. Insert and configure data types. Optimize tag insertion and configuration. Create and configure a new Modbus TCP communication driver. Optimize the entry and configuration of communication addresses. Install and configure the Modbus simulator. Run the application in Runtime Mode. Test tag connectivity by Data Watcher. Debug the application using RuntimeLog. Configure tag alarms. Configure event system. Configure alarm history. Configure database. Create tag group. Create and configure tag history. Insert images. Create and configure report. Configure the security system, user and profile. Create screens and pop-ups. Insert and configure screen objects. Associating tags with screen objects. Insert and configure symbols. Using and parameterizing system function. Inserting and configuring the trend object. How to deploy the application on the runtime machine. How the license system works. We will develop the application on a notebook using an engineering license, and after finishing the development, we will send the application to the runtime machine, which will be responsible for running the application on the final client. The runtime machine will use a runtime license of 150 tags. After downloading and installing the ADISRA SmartView software, open the engineering environment. Let's create a new project. To do so, click on the top left button and then click on New Project. After creating the project, in the top menu, in the Settings tab, define the resolution of the screens that will be shown in the viewer. We recommend keeping the screen resolution at which it will be used on the runtime machine. For our application, we will use the default resolution. In the navigation tree, right-click on the Tags document and create a new Tags document called project_tags. Insert two tags named Valve01 and Valve02. As the tags used in both valves have the same name, we will use the Datatype resource to standardize, organize, and speed up the tag creation process. Then, create a Datatype document called Valves. Note that throughout the development of the project, I'll be saving the application by clicking this button. Right-click on Datatype and then enter a new datatype. Rename the new datatype to Valves. Now let's insert the tags that will be used for the valves. For our hypothetical project, we'll use a list of tags as shown on the screen. So, as you can see from the project's tag list, each valve has 4 tags which it will represent status and command. Now let's change the type of each tag as shown in the project's tag list. Let's open the tags document, and then change the type to valves. Save the data type. Now change the type of the tags to valves. After doing so, subtags were created according to the selected data type. Now, let's configure the created subtags according to the list of tags. Let's insert the description of each tag according to the list of project tags. Repeat this process for the other tags. Let's also change the minimum and maximum value of the pressure tags, which are integer type. ADISRA SmartView allows you to export and import the tag spreadsheet to facilitate and speed up the tag creation process. So let's export the tags. Note that all tags and tag properties in the project can be changed via the .csv file. So let's change the tags and ownership of the tags for Valve 2. After making the changes, ensure that the structure of the worksheet has not been changed. If it has been changed, it will not be possible to import. After saving, import the .csv file. As you can see, all subtags have been configured. After inserting the application tags in the navigation tree, right-click on the driver's document and insert a new Modbus driver. Modbus communication will be TCP/IP, IP localhost, and Modbus TCP protocol. We will use a Modbus TCP simulator for communication. The reading of the variables will be every 1 second and the writing will be done whenever the value of a tag is changed. Let's add the list of addresses as per the list of tags in our hypothetical project. Let's insert the first tag, which will be associated with the Modbus address of valve command 01. To do this, click on the first line of the tag column and type valve and then type a dot. After that, the subtags of that tag will be shown. Select the CMD subtag. Repeat the same process for the other tags. Now, according to the list of project tags, let's associate Modbus addresses to each tag. The address of valve control 1 is address 2. We will keep this address as coil status and bit type. Repeat the same process for the other tags. Let's save the created Modbus driver. To make entering the addresses easier, we are going to use Microsoft Excel to copy and paste the tags and addresses. To copy the lines and columns of the Modbus driver, click on the left side of the first tag column, hold down the Shift keyboard button and then click on the last line. Open Microsoft Excel and paste this. This way, it becomes easier to create and change Modbus driver tags. So, now let's change the name of Valve 1 to Valve 2 and associate it to the respective Modbus addresses according to the list of project tags. That done, copy the changed lines and columns. Open the SmartView and then select the last line of the list of tags and paste the new lines. Don't forget to save driver changes. Note that each Modbus address has been associated with an application tag. After inserting and configuring the Modbus addresses, let's open the Modbus TCP simulator. The download link is available in the video description. So let's open the simulator. The simulator used is free for 45 minutes. Therefore, every 45 minutes it will be necessary to close and open it again. After opening the Modbus TCP simulator, let's run the application in runtime mode to test the Modbus TCP simulator's connectivity with ADISRA SmartView. This Modbus simulator is very simple to use. In this area there are several Modbus addresses. For example, in the first row, show addresses from 40001 to 40010. Each column to the right shows the current value of each address. Therefore, to change the address value 40001, this can be done in this field. If you want to change the value of address 40006, this can be done in this field. Note that the address list is showing addresses of type holding registers and decimal values. Later I will show how to read and write values in holding register and bits through SmartView. To run the application in runtime mode, click this button. The application is starting. Note that, in the RuntimeLog, it is possible to visualize the initialization of all modules. Since we haven't created a graphical display yet, we'll test it using Data Watcher. Then open Data Watcher. Click Load All Tags. Expand the Valve 01 and Valve 2 tags to show the subtags. Note that, after starting the application in runtime mode, communication was initiated and the tags associated with each Modbus address are receiving values from the simulator. For example, the tag valve01.pressure has a value of 0. All tags are being updated every 1 second and the tag quality is 192, that is, optimal quality. If the tag quality is below 192, the connection is not good. So let's do some tests by changing the values in the simulator and also in ADISRA SmartView. Note that after writing new values to the entire tags, the Modbus address associated with those tags has changed in the Modbus simulator. Now, to view the Boolean tag values in the simulator, change the holding register option to coil status. Note that the address book has changed. Now each simulator Modbus coil status address is shown. Let's change the value of Boolean tags and visualize the change of values in the simulator. It is also possible to change the values through the simulator by clicking on the field of each Modbus address. Let's also write values in the Modbus holding register addresses. As you can see, the values of the inner tags have changed in Data Watcher. In the engineering environment, there is a tab which shows the application log and runtime and engineering module. It is also possible to check the log of the searches made in the search menu and also if there are any errors in the compilation of the application. Note that after closing the Modbus TCP simulator, an error logo was shown, informing driver without connectivity. By right-clicking on the logs window, it is possible to clear, copy, filter, change the level, pause, save and export all log information. Note that after re-establishing communication with the Modbus simulator, the RuntimeLog started showing the Modbus communication log. Configure the tag alarm, reopen the project_tags document, and change the view mode to alarms. In this window, it is possible to enable the alarm conditions, the alarm messages which will appear in the alarm summary, the alarm limit, etc. Let's configure the alarms according to the list of tags in our hypothetical project. If you want, you can also insert and configure alarms by exporting the structure to a .csv file. So let's start by enabling the valve01.fail tags true alarm. Therefore, whenever this tag is set to true, this message will be shown in the alarms and events object, which we will add throughout the video. Repeat the same process for the other tags. For entire tags, according to the project's list of tags, the alarm for these tags must be defined with the high condition and value 90. Therefore, whenever the value of these tags is greater than 90, the alarm message will be shown in the control object. In the same window where we configured the alarms, we will configure the alarm history. In the right window, select in which database the alarms will be stored. For our application, we will use the proprietary ADISRA SmartView database. Then, in the Save History column, select which tags will be stored. In the Days to Keep column, select how many days the data will be kept in the owner database. In addition to the proprietary database, ADISRA SmartView allows integrating an external database. The configuration of external databases can be found in the Settings menu, and then in Database Connection. It is possible to integrate Microsoft SQL Server, MySQL, Postgres, SQLite, Microsoft Access, and Oracle databases. The Tags Group document allows you to group tags to be inserted in the Alarms and Events object, making insertion of tags faster and easier. To create a new tag group, access the Tags document, and then insert a tag group. We will divide the groups by valve. Then, for each group, add the respective tags. Let's add another group of tags. In the first group of tags, let's add all the tags for valve 1. In the second group of tags, let's add all the tags for valve 2. Save the tag group. In the navigation tree, right-click to create a new tag history document. For our application, we are only going to history the 2 pressure tags. Choose in which database the history will be stored. Then choose how often the data will be stored in the database. We will keep the history in the database for up to 180 days. ADISRA SmartView allows you to insert images into the application. After inserting, the image is saved in the application folder. During the development of the graphical displays, we will use this image. To create a report, in the navigation tree, right-click Report and then insert a new document. In the report settings, keep the report output as a file, add a name reports1, which will be the name of the generated file. And to generate the file, it can be in two ways. By placing a trigger tag in the trigger field, that is, every time the tag is true, the reports1.rtf file will be generated in the application folder. And the other way is using the svReport function, which will be used in our project. Now, let's create the reports interface. It is possible to insert chart, tables, data grid, and texts. First of all, let's insert the image that we inserted earlier. On the top menu, click Insert Image. Let's enter the title of the report. Let's also insert a text informing when the report was generated. To insert a tag into the report, type @ and then type the datetime tag. Select the report title and edit the text as shown. Now, in the top menu, click on the Insert Table button. Click on the table and in the Properties list, center align the table. Change the first row of the table as shown. Change the second row of the table as shown. Insert the pressure tag of each valve on the third line. Now, let's insert a chart object. To do so, on the top menu, click on the Insert Chart button. Click on the chart object and in the property list, keep the type property at pi. Enter two new series. The first call valve 01 and the second call valve 02. Now, associate the respective pressure tag of each valve to each series. ADISRA SmartView allows the developer to create a mechanism to manage the level of user access in runtime mode, i.e., depending on profile settings and/or user, an application grants or denies actions, such as clicking a button, starting or stopping an application, open the task manager, keyboard shortcuts, and others. In the top menu, access the Security tab. In addition to user management for runtime mode, it is also possible to protect the engineering environment. That is, if the application is opened in engineering mode, the developer must enter a password to access the application's engineering. For our hypothetical project, let's create profiles and users with specific privileges. Click on the Users and Profiles option. Let's create a user profile called Operator. Now let's create two users and associate them to the profile operator. Whenever a new user is created, it is initially necessary to put a password. For our example, I'll put the password 1, 2, and 3. Let's disable some privileges for the operator profile. Therefore, the user who is associated with the operator profile will not be able to open the task manager, cannot change tasks, and cannot use the electronic signature. Now, let's define the user's automatic logout, that is, after 10 minutes if the user does not interact with the application, the user will be logged out. We will start developing the interface for each screen in the application. To create a new screen, in the navigation tree, right-click Screens and then New Document. Save the screen as SCR00 frame. This will be the home screen of the application. Note that the screen was created with the screen resolution defined at the beginning of the video. Therefore, all screens will be created with this resolution. Create a screen called SCR01 valves. Change the canvas dimensions in the properties list as shown in the video. Create one more screen called SCR02 Alarm Events. Note that it is possible to copy and paste the screen using the Save As option. Create one more screen called SCR03 Trend. And finally, create a screen called Pop-up 01 Report. Open the frame screen to start the settings. Change the background color to gray. Use this slider to zoom in or out of the screen. Let's insert the ADISRA image. As this screen will be the initial screen of the project, this screen will be composed by the screen navigation system. So, to create a screen navigation system, let's add buttons to open each screen and a screen object to show the screens. Then, add a button and change the following properties. Let's replicate the button by pressing Ctrl+C and Ctrl+V and change the name for each button. Select all objects to arrange alignment and spacing. Now, let's insert the screen object. This object is intended to allow opening several screens in the same area. In this way, allowing navigation between screens. Throughout the video, we'll use a script on each button to set the screen object's screen. Let's standardize the width and height of the object. Then we'll need to update the width and height of the screens in relation to the screen object. Set the SCR01 valve screen as the home screen for the screen object. Now, let's insert in each button a script in the mouse up event to change the screen object's screen whenever the button is pressed. Note that every object on the screen has a name. The screen object is called Screen1. Open the Valves button script area and enter the following script. When typing Screen1, the properties of the screen object are shown. To change the current screen of the screen object, we will use the set property. So, the script will look like this. Now, let's replicate this script for each menu button and change the call for each screen created. In the Report button, the screen will not be opened in the screen object. The screen will be window type. Then, We can use the button properties to do some actions. For example, when selecting a button, we can choose whether an action will be by script or directly on the property. If you select the action option, 3 properties are shown. If the self-close property is selected, when clicking on the button, the current screen will be closed. The toggle tag property allows adding a tag. Then, whenever the button is clicked, the associated tag will have the value changed from false to true or true to false. And finally, the action's target property allows you to open a screen. So let's select the pop-up report. Save screen changes. Open the pop-up report screen and enable the dialog property. So whenever that pop-up is opened, that screen will have priority. Now, set the frame screen as the application's home screen. Then, whenever the runtime module is started, the viewer will automatically be opened, showing the frame screen as the initial application. Let's insert a label object and change the text property to user. Now, let's insert a text box object and associate the text property to the current user tag. To associate a tag with a text box object, select the Object and Properties list. Insert the tag in the text field using the @ symbol at the beginning of the tag name. With this, the user who is logged in the application will be shown in the text box. Other system tags can be found in the tags document called System Tags. Now let's add 2 buttons. One for user login and one for user logout. So, insert 2 button objects and change the text property to login and logout. Use the alignment tools to align the objects. Select the objects and use the alignment tools. In the script for each button, we'll add a function for login and logout. To learn about all the security system functions, access the System Functions Library document. The SV Security Library has several functions which can be used in the application. How each function works can be found in the help document. So, to add the function, access the button script, write the SV Security Library and then the login function. Repeat the process for the log off button. Now, let's show the system date and time on the screen. To do so, copy and paste the label and text box and replace it with the datetime tag. Let's add a rectangle object to create the menu designer. Change the fill color of the rectangle. Enter the value 7 in the corner radius property. Save the application. Open the valve screen and change the background color. Insert a rectangle and then a label with the screen name. So, in the top menu, insert a rectangle object, edit it and position it as shown. Now, insert a label object and edit the properties as shown. These two objects will represent the title of the screen. Now, let's insert the application's valves. To do so, in the top menu, click on the Symbols option. ADISRA SmartView provides a library of various symbols. Let's add the valve symbol. Select the valve and change the color mode property to shaded. Select the fill property and select the Dyn option. Place the valve01.status tag in the expression. Below, enter the color palette for the false and true values. So, whenever the valve01.status tag is false, the valve's color will be green, and if it's true, the valve's color will be red. Now we also need to animate when the valve is faulted. So, copy and paste the valve symbol, and we'll animate it through the object's visibility. Remove the color animations as we will be using the visibility property to animate the object. In the isVisible property of this new symbol, add the following script. So, whenever the valve01.fail tag is true, that is, in failure, the yellow symbol will be visible, showing that the valve is in failure. And if it is false, the symbol will be invisible. Place the yellow symbol on top of the previous symbol. Add a label to show the valve name. So, select the label object and put in the name of the valve. Select the label and valve objects, and use the alignment tools to center them. Add two buttons to send command to open and close the valve. On the Open button, add the following script. Then, whenever the Open button is pressed, the valve01.cmd tag will be assigned the value true. Repeat this process for the Close button. Insert a text box and associate the pressure tag to valve01. So, insert a text box object and edit the properties as shown. Next to the pressure tag, add the script beside it to add the engineering unit. Now, add a rectangle and in the Dyn fill property, associate the pressure tag to valve01 and change the color to blue. The filling of this rectangle will change according to the associated tag. So the vertical padding of this rectangle will be proportional to the value of the tag. Let's also add an object called slider. This object allows changing the value of an analog variable by moving the pointer. In the list of properties for that object, define the minimum and maximum according to the tag. And in the value property, associate the valve01.pressure tag. Let's add a rectangle as a background. I'm going to copy the rectangle used in the frame screen menu. Now, let's test the animation. Then start the application in Runtime Mode. Start the Modbus simulator. Now, let's change the value of the Modbus addresses which are associated with the status of the valve. Let's also test the open and close valve command buttons. Note that the value in the simulator has changed. Now let's test the pressure tags. Then, change the addresses for the holding register and change the value of the Modbus address associated with the pressure tag. As you can see, all animations are working as expected. The ADISRA SmartView has a document called Templates, which allows the user create object or a set of objects of an application in a library, in which can be shared across projects without having to redevelop each object, thus facilitating the development of repetitive objects. Next, we will create a template which will represent the valves. In the navigation tree, right-click on Templates and create a new document. Save as valve. Select all previously created objects to show valve status and paste into the new template. Change the dimensions of the template. Since we're not going to use all of the screen space, let's downsize. Now, to animate each object in a generic way, we need to create object tags. To do so, select the template and in the list of properties, insert each generic tag. So, create a generic tag to associate with each valve tag. Then, replace the previously created valve01 tags with the generic tags. To associate a generic tag with the object, type hashtag. In the script for each button, do the same process. Replace tags with generic tags using the hashtag symbol. On the valves, I also changed the tags to generic tags. After creating and saving the new template, add a template object. Now, select each template and pass the respective tags for each valve. Click on the canvas to insert the template. Copy and paste the template for the second valve. Use the alignment tools. Now, select each template and associate the tags with the respective generic tag. For the generic tag called names, since we don't have a unique tag for the name, let's change the description property of the status tags for each valve. As you can see, using templates, creating repetitive objects becomes easier and faster. So, let's test the animation of the templates. Let's start the Modbus simulator. As you can see, the animation worked as expected. Now let's insert and configure the application's alarm and events object. Open the alarm and events screen, change the background color, and insert the title bar as was done in the other screen. On the top menu, click on the Alarm and Events object and add it to the screen. The first alarm and event object will be responsible for showing the application's current alarms. Then, select the object, set the object type to Online, to show the current alarms. Below, define which columns will be shown in the object. The table on the right represents the columns that will appear in the Alarms and Events object. Next, let's add the tag alarms that will be shown on the object. As we created a group of tags, it is not necessary to insert one tag at a time. Let's insert the tag group created earlier. Now, copy and paste the label and the alarm and events object. Change the label to alarm and event history. Select the object and change the type to event and history. This way, the object will show the history of alarms and history of events. Below, define which columns will be shown in the object. Well, after inserting and configuring the alarms and events object, let's configure the storage and generation of events. Every generated event can be stored in the proprietary database or external database. To enable system event storage, on the Settings menu, click on the option. Enable the option Save Events to Disk and the option Never Delete History, and then select the owner database. From now on, any generated event will be stored in the proprietary database and the alarms and events object will show the generated events. To generate an event, you need to use the svEvent function library. For our application, we will add the event function to the valve control button. Then, whenever the open or close button is pressed, an event will be generated. Let's configure. Open the template and in the command buttons, add the following script. Then, whenever the button is pressed, the send function will be executed and will store the generated message, which will consist of the valve name, the command message, and the logged in user. Now, let's start the application in runtime mode to test the alarms and events. Let's start the Modbus simulator again. Note that when starting the application and opening the alarms and events screen, the alarm history object showed a previously generated alarm. Let's force an alarm and event. So, after changing the value of the valve 01.pressure tag to 91, an alarm was generated according to the threshold of the high condition. The alarms and events object, which shows the current alarms, allows the user to recognize and remove the generated alarm. Each condition is represented by a color. Now let's test the event generation. As you can see, it worked. The event was raised and shown on the object. If the application is restarted, the history of alarms and events will be shown in the object. Now, we will add the trend object, which aims to show the current and historical behavior of a tag. Then, open the trend screen, define the background color and the title bar according to the other screens created previously. To insert the trend object, in the upper menu, click on the trend option and click on the screen. Select the object and in the Properties list, add the two pressure tags. Note that in the list of properties of the trend object, it is possible to change several properties, such as enabling or disabling the cursor, starting paused, showing the toolbar, etc. In the Configuration tab, let's configure the added pens, that is, the tags in which they will be plotted in the trend. Let's start the application in Runtime Mode to test the trend object. Let's start the Modbus simulator again. Let's change the value on the Modbus addresses associated with the pressure tags. As you can see, variables are being plotted on the trend object according to the settings. Let's create the pop-up to save and open the report. Change the background color to gray. Change the screen dimensions for a pop-up. Add a rectangle. Add a button and change the text property to save report. Add another button and change the text property to open report. Select the Save Report button, and add the script to save a report. This script composed by the Save Report function. So let's create the script to save the report. Let's declare a variable called path as a string and assign it the project folder path. Then, add the save file function and in the first parameter, pass the value of the report to be saved and the path where it will be saved. Select the Open Report button and let's add the following script. Let's declare a variable called path as a string and assign it the project folder path. Then add the function to run a Windows application. Pass the path of the file where it will be executed. The file executed will be the report saved in PDF. So, to test the report, let's run the application in Runtime Mode and put some values in the tags. Let's start the Modbus simulator again. As you can see, the report generated and opened as expected. According to the script created in the button, the report was saved in the application folder where it can be found as follows. After developing the application on the development machine, we need to send the application to run on the runtime machine, that is, the runtime machine located on the final client. So, in the engineering environment, let's generate a shortcut to open the application in runtime mode without having to open the engineering environment. To do so, in the Settings menu, click on the General option and then click on Create Shortcut. A shortcut to open the application in runtime mode was generated on the desktop. Now we go in the Documents folder, and then ADISRA SmartView and move the project folder to the desktop. Select the application folder and the shortcut, and use the Windows compressor to reduce the file size. Then send the compressed file to the runtime machine. Extract the files. It is important to mention that, for the runtime shortcut to work correctly, the application folder must be placed in the same path. So, let's open the Windows Documents, the ADISRA SmartView folder and move the application folder. Now, test the application on the runtime machine. As you can see, the application ran in runtime mode. To use ADISRA SmartView, it is necessary to register it with a license according to purpose of use. A license can be stored on a physical key or a software key. So, for our hypothetical project, it was necessary to acquire an engineering license, in which it was necessary to develop the application on the engineering machine. And to run the application in runtime mode on the runtime machine, it was necessary to acquire a runtime license to support up to 150 tags. To access the license system, in the engineering environment, click on the License tab and then on Register. In this window and in the License tab, there is all the license information, such as, if the license is soft key or hard key, license validity, number of tags and viewers supported, if the license is engineering and runtime, if the license has both options, that is, more runtime engineering, the license number and below the code generation for activation. It is possible to access the license system through the Start menu, searching for the Register License executable. The license system has 4 types of license. Trial license. This license is provided upon installation of ADISRA SmartView. After 30 days, the license will expire, requiring at least one of the licenses below. This license allows access to the ADISRA SmartView engineering environment to develop the application using all available resources. After the application is developed, it is possible to run the application in runtime mode. However, there is a time limit of 2 hours, that is, the runtime mode will be closed if it exceeds the time of 2 hours and will continue this way every 2 hours. Engineering license. This license allows access to the ADISRA SmartView engineering environment to develop the application using all available resources. After the application is developed, it is possible to run the application in runtime mode. However, there is a time limit of 2 hours, that is, the runtime mode will be closed if it exceeds the time of 2 hours. Engineering license and runtime. This license allows access to the ADISRA SmartView engineering environment to develop the application using all available resources. After the application is developed, it is possible to run the application in runtime mode with unlimited time. Runtime license. This license does not allow access to the ADISRA SmartView engineering environment to develop the application, just run the application in runtime mode with unlimited time. Thanks for watching until the end. Visit the ADISRA website for more information or contact info@adisra.com or the sales team.